Howdy, stargazers, and welcome to this episode of Star Trails. My name is Drew, and I'll be your guide to the night sky for the week starting September the 8th to the 14th. On today's episode, we'll explore some of the most mysterious and powerful objects in the universe, quasars. We'll also take a trip through some of the prominent deep sky objects in the September sky, and fly along the Milky Way with the mythical swan, Cygnus. So grab a comfortable chair, some binoculars, or a telescope, and let's get started. This week the moon will transition from the waxing crescent to the waxing gibbous phase. Starting with around 30% illumination on September 8th, the moon will steadily grow brighter each night. It reaches the first quarter phase by September the 10th, and by week's end, 83% of its surface will be illuminated, making it a great time for evening lunar observations. Planetary observations remain much as they have in recent weeks. Mars is nearing a close approach with Earth, so it's becoming brighter. You can locate it near Gemini around 2 a.m. Jupiter is above and to the right near Taurus at a bright -2 magnitude. Saturn is visible from nearly dusk until dawn. Look for it making its way across the southern sky. It's not particularly high in the sky, so atmospheric turbulence may factor in your observations. However, it's at its closest point to Earth this month and will be at its brightest. Venus, outshined only by the moon, will be tough to catch this week as it's close to the setting sun. Mercury will be similarly lost in the morning sun's glare. A prominent constellation in September is Cygnus, the swan. Cygnus is easily recognizable by its cross-shaped pattern, also called the Northern Cross, and it's located along the Milky Way. It's well placed high in the sky during the evening, making it an ideal target for stargazing. Cygnus is home to several notable deep sky objects, including the North America Nebula, NGC 7000, and the bright star Deneb, which is one of the vertices of the Summer Triangle asterism. The constellation's position along the Milky Way also means that it's rich in star fields, making it rewarding to explore with binoculars or a telescope. In Greek mythology, Cygnus is often associated with several legends, each involving a swan. One myth links Cygnus to the story of Orpheus, the legendary musician and poet. After his tragic death, Orpheus was transformed into a swan and placed in the sky next to his lyre, represented by the nearby constellation Lyra, as a tribute to his musical talent. Another tale connects Cygnus to Zeus, the king of the gods, who transformed himself into a swan to seduce the mortal woman Leda, leading to the birth of the famous twins Castor and Pollux, who are represented by the constellation Gemini. The constellation's shape is often interpreted as a flying swan with the star Deneb marking the tail, while the other bright stars outline the wings and neck, evoking an image of a swan gliding along the Milky Way. In mid-September, the night sky offers a variety of deep sky objects perfect for observation. One of the highlights is the Andromeda Galaxy M31, which is visible to the naked eye and stunning through binoculars. Also, the Great Hercules Cluster, M13, is a dense ball of stars in the constellation Hercules. And don't forget the Ring Nebula, M57 in Lyra, known for its distinctive ring shape. The double cluster in Perseus and the Dumbbell Nebula M27 in Vulpecula are also excellent targets, offering breathtaking views through even modest telescopes. These objects provide a rich stargazing experience as the nights begin to lengthen. Today, I'd like to discuss some of the most mind-blowing phenomena out there. Quasars. These cosmic beacons are windows into the earliest chapters of our universe. Quasars are among the brightest and most energetic objects in the cosmos. The term quasar is short for quasi-stellar object. because when they were first discovered in the 1960s, they appeared star-like, just points of light in the night sky. But as astronomers began to study them more closely, they realized these objects weren't stars at all. In fact, they were something far more powerful. Quasars are actually the blazing cores of distant galaxies, powered by supermassive black holes that are voraciously consuming surrounding material. As gas and dust fall into the black hole, they heat up and emit staggering amounts of energy, sometimes outshining the entire galaxy in which they reside. The story begins in the 1950s and early 60s when radio astronomy was in its infancy. Astronomers were using radio telescopes to map the sky and discovered mysterious radio sources that didn't seem to correspond with any known objects. One of these sources, 3C273, located in the constellation Virgo, stood out. It was incredibly bright in radio wavelengths, but appeared as just a faint star in visible light. In 1963, astronomer Martin Schmidt at the California Institute of Technology made a breakthrough. He analyzed the spectrum of 3C273 and noticed something strange. These spectral lines were shifted far into the red part of the spectrum, a phenomenon known as redshift. This redshift indicated the object was moving away from us at an extraordinary speed, suggesting it was incredibly far away, billions of light years from Earth. Yet it was still bright enough to be seen, meaning it had to be emitting an enormous amount of energy. Schmidt's discovery confirmed that quasars were not nearby objects but distant, powerful beacons from the early universe. The engine at the heart of every quasar is a supermassive black hole, millions to billions of times the mass of our Sun. Black holes are known for their ability to pull in everything around them, even light. But in the case of quasars, as material gets sucked into the black hole's immense gravity, it doesn't just disappear. Instead, it forms a swirling accretion disk around the black hole. This disk is where the magic happens. The intense gravitational forces cause the material to heat up to millions of degrees, emitting energy across the entire electromagnetic spectrum, from radio waves to visible light to X-rays. It's this radiation that we observe from Earth, and it's what makes quasars so incredibly luminous. Because of their extreme brightness, quasars can be seen from farther away than almost any other type of astronomical object. This makes them valuable tools for astronomers studying the formation and evolution of galaxies. By analyzing the light from quasars, scientists can learn about the conditions in the universe when these ancient objects were alive, a time when galaxies were just beginning to form and evolve. Some quasars even emit jets of particles that travel at nearly the speed of light, stretching across hundreds of thousands of light years. Now, you may be wondering, can I see a quasar with my backyard telescope? The answer is yes, with a bit of patience and the right equipment. While quasars are incredibly bright, they're also very far away, so they appear as faint points of light. But don't let that discourage you. Spotting a quasar can be a rewarding challenge. Quasar 3C273, which I mentioned earlier, remains one of the brightest in our sky. If you have a decent telescope, you can find it as a tiny star-like point. Just remember, when you're looking at that faint dot, you're gazing across billions of light years, truly seeing into the past. And one more thing, let's clear up a common mix-up: quasars and pulsars. They sound familiar, but they're very different. A pulsar is a rapidly rotating neutron star that emits beams of radiation, while a quasar is the core of an active galaxy powered by a supermassive black hole. Both are fascinating, but they operate on entirely different scales and principles. I covered pulsars back in episode 31, so check that out in case you missed it. With new telescopes like the James Webb Space Telescope, we're poised to learn even more about quasars and the distant reaches of the universe. Who knows what new cosmic mysteries we'll uncover next? In the meantime, these beacons from the early universe still offer us a glimpse into a time when the cosmos was still young and full of violent, energetic activity. That's it for today's episode of Star Trails. Before you go, I invite you to check out our weekly email newsletter on Substack. It's completely free and a great supplement to the podcast. We're also on Mastodon at *_trails. If you get a chance, stop by and say hello, and I'll include links to both services in the show notes. Also, remember our website, startrails.show, where you can find all of our episodes, including transcripts and night sky maps. Until next time, keep looking up and exploring the night sky. Clear skies, everyone.